Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the second lecture of this week of ongoing online course on engineering or architectural graphics part 2, and in this particular week we are learning about how to draw axonometric drawings. Yesterday I explained to you what is axonometric projection and what are the various types of axonometric projections, isometric projection being one of them. And what we are going to continue in the remaining 4 lectures of this week is how to draw axonometric projection, which is what we are treating as synonymous to military projection. So, today we are going to look at how to draw 2D objects or planar figures, quadrilaterals, circles and curves in axonometric drawing. Very simply, if we have to draw any rectilinear object in axonometric drawing and if it is in a plane parallel to HP, there is no change in the object, it is just rotated by 45 degrees, which is what the concept of axonometric drawing is. So, if we are looking at this square in plan, this square will remain a square, it is just that it will rotate by 45 degrees. So, what we will have? Whatever the dimension is, we will have the same dimension here. The angle which we will take is 45, 45, and since it was right 90, this will remain as 90 and the dimensions remain exactly the same. Now, if this square was a plane perpendicular to both the planes, then now here you must remember that where this axis is. So, the axis, I am talking about the reference planes. So, we are assuming that the axis is like this and there is a reference plane like this and there is another reference plane like this. This is what we are seeing. Okay. Now, if we have to if this plane, the square plane was perpendicular to both the planes, then what we have? So, you can, for your reference, you can draw these axes again. This is 45, 45 and 90. Okay. So, what we have here is 45, perpendicular, perpendicular and this, and the dimensions remain exactly the same. And if it was a plane which was perpendicular to HP and parallel to VP, we would have drawn it here with the same dimensions. So, 40, 40, 40 and this is how the square plane which is perpendicular to HP and parallel to VP would look like. Okay. It is easiest to draw them in plans using axonometric. If it is a rectangle, again we can simply see how we are making this rectangle. So, what we are doing here is just making a simple rectangle. The angle remains 90. Okay. If it is parallel to HP. Now, if we have it perpendicular to HP and VP both, again what we would do is we would make it the vertical 45, vertical and 45 and the dimension will remain the same. If it is perpendicular to HP but parallel to VP, so we have the same thing here but the other side, right. So, it is 45 perpendicular, 45 perpendicular. Now, you have to again remember the same fundamental. If we are talking about a height, a vertical edge which is vertical to the horizontal plane, the reference plane, it will appear as a vertical line, a straight line, and the parallels remain parallel. So, which is what we are seeing. If it is parallel to this, it will always be seen as parallel. Okay. These two are parallel, these two will appear to be parallel in whatever plane, in whatever position we will view it in axonometric. Now, triangle. If we were to draw this triangle in plan, it is very easy, unlike in isometric. What we will do simply here is, now this is the triangle here. I may not even need this PQ. Okay. So, all I will have to do is that this line AB I will draw at a 45 degree. Okay. And then from this I can take this length and draw. So, I can simply reconstruct the triangle, or if I am not knowing what the dimension of what's the length of these sides, because this angle will change. So, if it is 45, we would know that this is 45 and this is 45. The angles will remain the same with reference to this line, and total we would know. Okay, so I should draw it correctly. If this is 45 and if we take this as 45, then this side will appear to be a perpendicular line, and then this is 60. So, probably I am doing some error in checking the angles, but this is how it will be. Or alternatively, you could draw the rectangle and then arrive at the point C by measuring this distance. Okay. So, all we are doing is taking this. Now, if we were to draw it in a plane which is perpendicular to both the reference planes, we will do the same thing as we did for isometric. So, we will locate the point and it will become slightly skewed, but this one remains 45. Okay. And the same we will do here on the other side. We will identify the point with the help of this rectangle, and then we get this. It is only when the plane is parallel to HP that these angles remain the same, but in both the other planes, the vertical planes, the angles will not be the same and we cannot measure. Okay. So, that you have to keep in mind. It is very easy to draw the plans in a plane which is parallel to HP using axonometric. That is the reason why axonometric drawing or military drawing is more commonly used for making architectural plans. Okay. Again, so if you remember these examples, we are taking the same examples as we took for isometric drawings, and I am just drawing it very fast, showing you that it is the procedure is exactly the same as isometric drawing, but the resultant figure will be slightly different from what we got in isometric, simply because there is a different angle that we are looking at it from. So, if it is this, again 45, 45, you draw the rectangle, or if you knew the angles, you could measure the angles and draw the. So, this we can take the distances and then arrive at these points. So, this is how your quadrilateral is going to look like. Okay, a polygon is going to look like. Again, if you were to look at it in vertical plane, you will measure, arrive at these points and draw. Very similar to what we have been doing in isometric. Just that your parallel lines will remain parallel and you can measure these distances. Okay. Similarly, you can draw the pentagon. Plans remain the same. we might not need to draw the rectangles if it is only going to be seen in the plan. You can directly rotate this entire drawing by 45 degree, which is how we were doing in orthographic projections, if you remember. So, if we were seeing a plan which was rotated by 45 degrees, we would draw the plan and rotate it by 45 degrees, which is what we can do. Okay. So, we do not need to arrive at this by drawing an enclosing rectangle. We can directly draw the plan, the pentagon. But if we are to take it in a plane which is perpendicular, there we will need the reference rectangle. Okay. So, that is what the procedure is going to be. So, for drawing the vertical planes, the procedure is exactly the same as isometric drawings, isometric projections, and for plans it is much simpler. It is just a simple rotation of 45 degrees. So, any drawing for that matter you can take. I can start with this. So, 45 degrees of hexagon here, and we can use the same process as we did for the geometrical construction. I do not even need to make this rectangle, and we can arrive at this hexagon by geometrical construction. Okay. This is in plan, when it is seen in plan. For the elevation, again use the reference rectangle and you get the resultant object. You could do it for the other vertical plane. Now, the circle is very interesting. So, the circle in plan will appear to be a circle because the angles do not change, it remains 90 degree only. So, the square which contains the circle remains the square. If we were to look at it as the process which we got from isometric projection, so the center remains the center and the distance, all these distances are the same. So, the circle will be a circle in plan in axonometric, in military projection. So, we will not get an ellipse if we are seeing it in plan, but when we are drawing it here, so try drawing this. This is the square which encloses, and now if you see this, so though these distances, these 4 distances, they remain the same, but the angle has changed, it is not 90 degree anymore. So, what you will probably get when you use the same isometric projections, we will get approximately, this. The same procedure as we got for the isometric, using the same centers, and it will be an ellipse, which is what we will arrive at when we draw axonometrics too. It is just that the angle is slightly changed, and the same thing to the other side. We will get these 4 points, the midpoints. Okay. Draw the perpendiculars, you get the centers, use the same process exactly, and you get an ellipse, but it is slightly different from how you would have arrived, the shape that you would have arrived at in isometric projections. That is what we are getting. So, this is more or less, it appears like an isometric because probably the angles that I have taken, it is less than 45, but if you take exactly 45, this is, you will get a flatter ellipse, a very skewed ellipse, because the vertical planes, they get quite skewed in axonometric projections. The same, exactly the same thing we will do when we are doing semicircles. So, if you look at this is where our semicircle is going to be. So, in the plan, the semicircle will remain a semicircle, it will not change to be an ellipse. Now, draw this in vertical plane. And we get the same thing. So, we have these points, but the angle has changed. So, again we will extend and what we will get is a skewed semicircle like this. So, we do not need to complete, we just need to arrive at the centers for drawing this. Okay. So, arriving at the centers and then drawing the curved part of this semicircle. So, this is how we are going to be drawing the axonometrics. You could take any shape or any orientation. All we have to understand is that what is the plane which is containing, is it parallel to HP, it is perpendicular to HP, perpendicular to VP. So, what its orientation is going to be, and then accordingly we will start drawing these shapes. So, I will stop here for my second lecture, where we have covered all the two-dimensional objects. You can try working them out. All we have to do is identify where this center is going to be. So, I am just drawing it in plan, you can draw it in the vertical plane. So, what we have done here is exactly located the centers of this, and the circle, the quadrant remains a circle straight. Now, try drawing it in vertical planes, both the vertical planes, and see the kind of shape do you get and how different this shape in axonometric is from the isometric drawing. So, thank you very much for joining with me today in this lecture. In the next lecture, in fact, in the remaining lectures, we will start going over the 3D objects and how to draw them in axonometric. So, thank you very much for being here with me. Have a great day. Bye-bye.